Hey folks, my name is Jared Hillam. I'm the Go-to-Market VP at BladeBridge, and I'm going to talk about automating modernization. And we'll go into a configuration-based automation of legacy tech to the Databricks Lakehouse. So let's talk about the problem first. What makes data management solutions very sticky is that the runtime environment is ran by logic that is embedded into their systems, whether it's through metadata or code. That logic is stored in those systems. So the question is, how do we get that to work within a Databricks runtime? Well, we got to convert that code. And so that's a tremendously difficult thing to do because you've got to go through a code conversion process. And there's a lot of organizations that have attempted to do this, and it's a hard problem to solve. You see organizations trying to do it as consulting, so they'll sell consulting, but they'll kind of pitch it as a product. And those have their own issues. It can't scale to the market. It's usually an over-the-wall relationship where you give them code and they send code back. And that means you have to give up your metadata or your code. And it's limited to the number of sources and targets you can go to, just simply because you can't grow a consulting organization large enough to address all of the market. Then you have the one-hit wonders. These are singular technology folks that are addressing one type of conversion, one method of conversion, one platform from another. They get stuck really easily because they're really focused on one technology. So when they're within a project, it's very common for them to get stuck when it says, hey, now we need to convert SQL that's embedded here, or now we need to convert this enterprise scheduler or other things that are there. So it's not configurable enough. And then you just have the consulting army approach, which is a real problem. You end up sharding the patterns of the legacy code in the target code because everybody has their own coding methods. So what this results in is lost custody of the logic. So imagine you have all of these developers recoding all of this logic from legacy environments now to Databricks. And now you discover, let's just say 80% through the project, oh, there's this data type difference that we need to account for. Or in another project we've seen, we saw an entire enterprise scheduler go unnoticed, and then they had to go back and set all of the enterprise scheduling tags within the code. So there's no going back if you're hand coding everything. Everything has to be hand done again. So there's a lot of rework, and thus it's just not scalable to a real project. So this is where BladeBridge comes into the picture. So let's just talk about what BladeBridge Converter is. Converter is a piece of software that's designed for migrating code and metadata, which is focused on data management technologies. And the fact that it's software makes it innately different from competing solutions. It's software that you can use locally, and you don't have to use some third-party service. You don't have to be connected to the cloud while you do it. And so users don't have to trust that BladeBridge is going to hold their metadata or something like that. You don't have to deal with those legal issues of data sharing. So instead of taking the data to the tool, we take the tool to the data. Converter is also not a black box solution. Rather, it's an engine with externalized configuration files. And because the files are externalized, you have the ability to edit them. If you have the ability to edit them, that means you can adapt those files to basically any kind of pattern that you see. And you can inherit from our base configurations, create your own naming conventions, future naming conventions, make your own adjustments to whatever enterprise scheduling tools you have. All of these configurations are open to you to manipulate. Another big difference is the robust community that BladeBridge already has ready. And so there's a lot of partners out there that have BladeBridge resources that can help you through a conversion. They can help you quote out the process, which we'll talk a little bit more about in later slides. So I want to first get everybody's head into the high-level process of how to run BladeBridge Converter. First, what you're going to be doing is conditioning our base configuration files. So naming conventions, any high-level errors that we're seeing, any enterprise scheduling tools, environmental variables, those kinds of things, you're going to want to condition the configuration files to all of those elements. And then as you've conditioned, which usually takes about 1 to 2 weeks, then you'll start going into conversion. As you start to convert, you're going to have jobs that pass, of course, but you also have jobs that fail. So what do you do when a job fails a unit test? Well, what you do is you begin looking at the patterns of the failures. So if you have a really high pattern count, let's say you have a job that has some embedded code and Converter was unable to convert it. And let's say that that job occurs repetitiously in code about 400 times in the legacy environment. And so what you would do is prioritize those jobs for configuration or adaptation. So you'd open the configuration file, adapt that pattern, and then rerun the converter, and all of those jobs will convert. So then you go to the next highest, and then the next, and then the next, and the next, and the next, and the next, and the next. So you progressively go down the economies of scale until you get to such low pattern counts where it ceases to make sense to address conversion through configuration. And that's somewhere between 80 to 95% of the code. You'll get through about 80 to 95% of the code where you get to a certain point where the number of jobs that you're impacting by editing the configuration file just gets too low to justify. The remaining 5 to 20% of code just end up being snippets you can edit by hand, just because the pattern counts are that low. And by the way, you're not actually rebuilding those jobs. You're literally just opening the converted code and then modifying those snippets of code so that they'll pass their unit test. So by doing it this way, by controlling all of the code through configuration, it means that you're controlling all of the code as a body and not just individual snippets here and there like you would as if you were doing it by hand. So there's a lot of power encapsulated in the idea of running your conversion through configuration. So the skill sets required in doing a code conversion are just really focused on the configuration side and the execution side. So you have a conversion architect that's focused on conditioning and adapting the configuration files, and you have a conversion specialist that's focused on taking those configurations and executing the converter and testing the output to validate whether it's converted or not, and then cycling back with the conversion architects on any edits that need to be made. So a conversion architect needs to have experience in regular expressions, the metadata for the source and the target, and system architecture experience so that they understand why they're coding a pattern in a certain way. And then also nice to haves would be programming language experience like Python or Perl. Now the conversion specialists, they need to understand, source technology, target technology, debug skills, issue resolution skills, and identifying of patterns. So let's step through now what the configuration and execution look like. So first, let's talk about the configuration files. These are loosely coupled readers and writers. So there's a legacy tech reader and there's a modern tech writer. And then you have a bridge between the reader and writer. And this loose coupling of all of our configuration files enables us to mix and match very, very quickly to any kind of different technologies that we're dealing with. And by the way, these configuration files are typically in JSON. Some of our older configurations are INI files, but for the most part, you'll see JSON as the file format for these configuration files. So to prep for a conversion, the first thing that needs to happen is that either the systems integrator or customer need to acquire the metadata from the legacy ETL or legacy database. So in the case of a database, it's going to be usually a SQL file. In the case of an ETL tool, it's going to be an XML file. And in other cases, there are different kinds of files that can be provided. But in most cases, that's what we'll be seeing. Now, on the target side, Databricks gives us PySpark, DBSQL. Now, there's a lot of other languages that, of course, Databricks provides us, but those usually are the most parallel to the types of conversion work that you would normally see. And then as you're converting, you'll iterate with the configuration files to ensure that you can pass your unit tests and continuously go through and convert the jobs into Databricks-centric logic. So if we go into a more detailed view of what this project might look like, first you're going to run Analyzer, which I haven't talked about yet, but I will here in just a minute. Then what you'll do is you start your project, you're conditioning the configuration files, and then converting those jobs. And it's either going to compile pass or compile fail. And if you have a fail, you go in and adapt the configurations, the same configuration files that you conditioned earlier. You're just going to adapt those configuration files and then go run those jobs again until you get a compile pass. And then you go into parallel testing. We have a tool called Data Recon that allows us to parallel test the databases. So you run a query on one, run a query on another, the legacy and the new, and compare those two and validate that all of the data came out the same. And if the parallel test passes, then you're good. If the parallel test fails and it's a high pattern count, then you'll want to push it back into the conversion process, that cycle, and run it through again, edit the configuration files, and convert again. And you'll notice this grayed outline is the low patterns. So if you have something that's a really low pattern and it doesn't make sense to convert through automation, those tweaks would get pushed to manual intervention. So let's take a quick look at some of the configurations that are already available. So we have Teradata to Databricks SQL. We have Hive to Databricks SQL. We have T-SQL to Databricks SQL. We have DataStage to Databricks SQL, as well as DataStage to Databricks PySpark. We also have Informatica to Databricks PySpark, and we have Informatica to Databricks SQL. Now, we also can configure basically to any route, from any to any. So there's just a question of how much configuration time would it take for us to deal with that. And this is actually something we're amazingly good at. We can create new configurations very, very quickly. So if you have a piece of technology that you have in your environment, we can definitely configure for it. And the duration to do so is measured in days and not months. Now, to determine the cost and the effort, what we have is something called BladeBridge Analyzer. Analyzer is a command line utility. It's very portable, and it allows you to scan the metadata from your legacy environment. So if you have an ETL tool or a database, what you'll do is just extract that metadata. So if it's an ETL tool, it's going to be usually an XML file. If it's a database, it's usually SQL, but you'll extract it into a folder, and then you'll point Analyzer to that folder. What Analyzer will do is produce an Excel spreadsheet with about 20 tabs on it with different levels of detail about that source. But one of the key pieces of information is a little grid that shows us a level of complexity: low, medium, complex, and very complex. Those values go directly into a calculator that BladeBridge provides to its systems integrator partners, as well as to customers that buy Analyzer. They can then evaluate the level of effort to do a conversion. Now, if you're interested in becoming a BladeBridge partner, we have a 3-page agreement that enables you to have access to the BladeBridge portal assets. One of the requirements is that there's a $5K subscription to Analyzer, which enables you to have Analyzer for the course of a year. And then we'll do some onboarding enablement, get you Analyzer keys. There's sales and pre-sales guidance that we'll step you through. There's project assets. And then there's a lot of demo jobs that are already pre-written and ready, keyed, that you can use to go and do demos, as well as work on for training your staff. Now, the path to doing your first engagement is that BladeBridge will typically help you in interpreting Analyzer. We'll jointly review the pricing calculator, and then we'll evaluate how much assistance you need from BladeBridge during your project. So usually there's a little bit of overlap for first timers. Now, for every $10,000 in software you spend with BladeBridge, we will allocate an hour of support time. So that's how our support gets built into our contracts. So anything beyond that you need, we can build in as a professional services overlap. And typically the overlap is somewhere between 2 to 5 weeks of involvement in your project. Then a purchase order for the software, and then we'll do some configuration training on your specific configuration that you're looking to convert. And then we'll generate the keys, and then BladeBridge Professional Services will typically assist you in that overlap time as you're converting. And that's really all of it. If you're interested in learning more about BladeBridge and connecting with me directly, I'd be happy to chat with you. My email address is jhillam@bladebridge.com. Now on deck, we're going to have Simon Eligolashvili, our creator and co-founder, do a demo of BladeBridge Converter. Simon, over to you.
Hello and welcome to the presentation of BladeBridge Converter. I'll demonstrate how to convert a DataStage job to Databricks SQL. For that, I'll use one of our converters that will take a DataStage job that looks like this, and we'll convert it to SQL, Databricks SQL with markdowns, fully compatible with Databricks. To run our converters, I'll use command line. All of our converters are command line utilities. And if I execute our converter from the command line without any options, it will give me a short help. So ds to any. Typically, our converters take these parameters. License key file, either a single input file or a folder with multiple files and subfolders. The output folder, the code generation language, so it could be just plain DBSQL, it could be DBSQL with Markdown, so it's easily ingestible into Databricks Notebook, could be Databricks PySpark as well, we support that. And very important, there's a config file that comes with each one of our conversions. So our converters are not black boxes, they're actually configurable, so you can drive how exactly the code can be generated, whether it's whether you're setting up standards around naming conventions or perhaps data frame styling and some other options that are available for code production using our converters. All right, so another important aspect of our converters is that the converters never go into any production repository. The code can be exported into a local file system. If it's DataStage, it's going to be in the form of XML file, and converter will access that XML file without being, intrusive and going into the actual DataStage repository. Okay, so my full command will look like this. Basically, I'm setting up some environment variables, set up my root folder, set up the configuration file that I want to use, and I'll go into the configuration file in a bit. And this is my full command. So the executable, the license key file, the code generation mode, which is going to be Databricks. This is a system config file that tells our reader how to interpret DataStage components, and the output folder into which the code will get generated. This is our root folder with the bat file that I was just showing you. My input folder is this. So I have one XML file with a DataStage job. I also have analyzer report, which is important to mention. One of the utilities that we provide is called analyzer, and all it does is it scans the source code and produces, if you will, an MRI image of your source code and tells you what's inside the code, the complexities, all the functions being used, and so on. And here's an example of it. So I just scanned that one job. The total count of jobs is 1, as expected. It's a medium complexity job. We published the algorithm that we use to measure complexity. It's a parallel job. Some job details. The types of components that occur in the source code. So this could be, the counts could be in hundreds or thousands, depending on the footprint of the code base. Information about or mapping between the jobs and the types of components. So if we had more jobs, obviously this table would have been longer. And very important, the list of functions that are being used. So one of the reasons why we use this tab is because we want to map all the functions in our config files to the output patterns. And typically converters come pre-configured, but this is the open part of the converter, so you can drive in case you want to change output patterns to what you want to map these outputs. So there's quite a lot of important information that can be used in the beginning for scoping the project, as well as a guide during the conversion project itself. So going back to the converter, so I'm going to go ahead and run the converter. Again, I'm running this command. My output folder currently is empty. There's nothing in here. So one of the things that I can instruct the converter to do is not only to convert the job and translate all the components, but also in case we're using flat files on the input and output, which is not uncommon within DataStage environment, we can translate that to table DDLs and make the output code look like as if we were writing two intermediary tables and not two flat files. So I'm going to go ahead and run the converter. DS2. Okay. And I'm going to go back and navigate to my output folder. So the converter started to produce some code. So these are DDL files that we can use to build intermediary tables in Databricks. And these are all Delta tables. And now it's converting the job itself. So this is my output file containing the job. So I told the converter not to generate just a plain SQL file, but to generate a Python file where I have all the SQL statements wrapped in Python constructs that Databricks supports. Okay, so the output code is in Databricks Markdown, so not only I can easily import it into just regular Notepad, but I can also import it into Databricks Notebook, which I'm going to do now. And once I do that, every cell that I have on the screen represents each processing stage. So the first stage of processing is really just setting up the widgets or job variables. So I can run this and I'll have my widgets appearing at the top. And then every cell in this notebook represents basically a link, because in DataStage it's the links that contain the information, and they're typically uniquely named, but if there's duplication in the naming of the links, the converter will actually rename them automatically. So let me give you an example of what the converter did. So I'm going to open up this transform. If I scroll down a little bit, I will see that there are some DataStage specific functions that are being used, namely the field function. This output is called toSec. So if I scroll to if I go back to Notepad and look for toSec data frame, we will see this representation of the logic in DBSQL, Databricks SQL, but also the function called toField or field gets converted to a combination of split and the index. Okay, and the reason why we have -1 here is because in DataStage the field function is 1 based, whereas the split function in Databricks is 0 based. That's why we need to subtract 1 from the index. Now, how does the converter know how to convert expressions and function calls? So this is where the configuration file comes in handy. One of the things that I mentioned in the beginning is that the converter takes configuration file as one of the inputs. Right here. And this is that configuration file. Now, within this configuration file, there are quite a few options that I can set up. But one of the more frequently changing places within this config file is the way we translate DataStage expressions and the embedded SQL code. So converter can do dual conversion. It can convert both the DataStage pipeline, but also it can penetrate the embedded SQL statements and convert those as well. And obviously the from component of those conversions will be different, and for that reason, within the converter we provide two configuration files that actually do the translations. So we have ETL converter config file, which is called DataStage to Delta Lake. Another file for SQL translations, and this is embedded SQL translations. Let's say we're converting from a combination of DataStage and Oracle, so this combination of the two config files would be appropriate. Now, if I open up this file, DataStage to Data Lake, there are several sections in here, so we can do line level substitutions. Those could be as simple as regex substitutions, but also we have a section where we line up our function mappings. So for example, if we take function string to decimal in DataStage, we want to specify the output template when it comes to converting that function call to Databricks. And my expression here is cast first argument as numeric. The filled function got converted to this expression, so basically split, open parentheses, first argument, second argument, and third argument -1, just to adjust the index. I can also variate between different versions of the same function call. So for example, I can say that if trim function has L as the third argument, then my output template is going to be regex p replace. Otherwise, it's going to be just plain trim. So these are types of things that you can do with the converter. This file can grow infinitely. Typically, we see this file growing to about 100 to 200 functions per project. And obviously, the out-of-box config file always grows with every iteration. And again, the result is a functional Databricks notebook that can be executed either fully or cell by cell for debugging purposes. All the statements are segregated into cells, and every cell actually contains annotation as to what it represents. So for example, this cell represents this as the original node, and this is the link, and so on. So it's easily traceable what exactly the converter is doing when it comes to comparing the original DataStage code and the resulting Databricks SQL. And that concludes the presentation part of the conversion. Thank you very much.
Thanks so much, Simon. We hope you enjoy the rest of Summit. If you'd like to reach out to us and talk about your conversion requirements, let us know. My email address is below.